So the second part of this mini series of lessons, or mini pair of lessons, is about ionic equations. And again, it's higher tier, and we're going to look at what ionic equations are, how we write them, and again why they can be useful to us. So it's very similar to the half equation. So what are ionic equations? That's first step. Very similar to half equations. They're like two half equations that have been joined together, and they focus entirely on the things changing their charge in a reaction. And most often it just contains metals. The difference between half equations is it shows both things that are changing their states in the same equation. So that's why it's like two half equations put together. So here's an example. We've got zinc plus copper sulfate, and it's going to make copper plus zinc sulfate. This is a standard displacement reaction. You get zinc powder, you get your copper sulfate solution, you drop the zinc powder into the copper sulfate solution, give it a stir, and what happens is the copper comes out of solution and you end up with like a browny orangey formation on the zinc, and the copper sulfate turns from a blue to a clear solution as we make our zinc sulfate. The equation looks a little bit like this. We've got our zinc solid plus our copper sulfate aqueous makes our copper solid and zinc sulfate aqueous. And we can see here I've tried to separate the colours. The zinc is red on both sides, the copper is green on both sides. First thing is we're going to write out the simple equation, but we're going to break it up into the individual ions. The zinc on the left hand side stays just the zinc because it's not joined in an ionic compound, it's by itself, and it has a zero charge on it, so we don't need to write the charge. The copper and the sulfate are going to break apart though, and we're going to make Cu2+, and seeing as this is an ionic compound and it has no charge on it, if the copper has got a 2 charge plus 2 charge on it, it means the sulfate must be -2. So we're going to have Cu2+ plus SO4 2-, and on the right hand side, copper is elemental, so it's going to be just Cu, no charge. The zinc this time is attached to the sulfate, so it's going to be Zn2+ plus SO4 2- like this here. Now I've omitted the state symbols just to make it a little bit clearer, but this would be our simple equation broken up into the ions. Zinc plus copper 2+ plus sulfate makes copper plus zinc 2+ plus the sulfate 2-. Step 2 is remove any ions that don't change state or don't change their charge, and we can see this time the sulfur stays as SO4 2- on both sides, so we can cancel those out just like in a mathematical equation. Those two cancel out and we get left with then Zn plus Cu2+ makes Cu plus Zn2+, and that's our ionic equation. Quite simple. We can then break this down into two half equations, making sure to show the electrons, spelling mistake there, if needed. So we can break it down to the zinc goes to zinc 2+ plus 2 electrons, and copper goes copper 2+ plus 2 electrons makes the copper. So we can break it down into the half equations. Another example, going back to our thermal reaction between iron oxide and aluminium to make aluminium oxide and iron. We get our equation written out again like it was here earlier on in the last lesson. Fe2O3 plus 2Al makes Al2O3 plus 2Fe. So we're going to write out that simple equation, but we're going to break it up into our ions. So this time we get 2Fe3 plus our 3O2-. So again we've broken this down into the ions it's representing. So not O3 6-, although you could write that. But 3O2- is perhaps the more correct way of writing it. And to this we add our 2 aluminiums, and we're going to make 2 aluminium 3+ plus our 3 O2- plus our 2 ions. Next step, just like before, we remove the species that don't change charge, and in this time it's the oxygen that stays with 2-, 2-, whereas the iron goes from 3+ to 0. And the aluminium goes from 0 to 3+. So we're going to remove the oxygens, which gives 2 Fe3+ plus 2 aluminiums makes 2 aluminium 3+ plus 2 ions. And the step 3, it's a semi-optional step here, is we can simplify that equation. We can see we've got 2, 2, 2, 2, so we can divide it all by 2, and simplified it gets Fe3+ plus aluminium makes aluminium 3+ plus iron. Okay, so that's the basics of ionic equations. It's very simple, very similar to that. And a little summary of it. So ionic equations show the ions that change charge during a reaction. So the ions that get oxidized and reduced in a reaction, the ions that gain and lose electrons. It's useful for identifying what gets oxidized and reduced using oil rig. Oxidation is loss of electrons, reduction is gain of electrons. If the charge becomes more negative, then it's gained electrons, it's been reduced. If the charge becomes positive or more positive, then it has lost electrons, so it gets oxidized. Okay guys, I hope you found this video useful. If you've got any questions, please leave them in the comments below. I think the Ionic equation is a bit more simple once you understand the half equations, and you can bear in mind as well that a Ionic equation essentially is two half equations put together. The reason why the electrons don't show up in them is because the electrons would cancel out, just like the sulfate and oxide ions in our examples here, which get called spectator ions because they're not actually changing in the chemical reaction, they're just swapping. Okay, take care guys, I hope to see you in another video soon. Bye bye.